Hello everyone. Today we are going to discuss about normal forms in DBMS. Normalization. Normalization is the process of organizing the data in the database. Normalization is used to minimize the redundancy from a relation or set of relation. The redundancy in a relation may cause insertion, deletion, and update anomalies. So it helps to minimize the redundancy in a relation. The normal forms are used to eliminate or reduce redundancy in a database tables. The types of normal forms are the first normal form, second normal form, and third normal form. The first normal form. A relation will be in first normal form if the domain of an attribute must include only atomic values. It states that an attribute of table cannot hold multiple values. It must hold only single valued attribute. The first normal form disallows the multi-valued attribute, the composite attribute, and their combinations. This is the example of an first normal form. The relation student in table 1 is not in first normal form because multi-valued attribute student form. Its decomposition into first normal form has been shown in the table 2. Another example of an first normal form. Consider the table. In the above table, course is a multi-valued attribute, so it is not in 1NF. Below the table, decomposition into first normal form, so there is a no multi-valued attribute. Next one is second normal form. To be in second normal form, a relation must be in a first normal form and a relation must not contain any partial dependency. A relation in second normal form if it has no partial dependency. A non-prime attribute is dependent on any proper subset of any candidate key of the table. The non-prime attributes means attributes which are not part of any candidate key. The partial dependency. If the proper subset of candidate key determines non-prime attribute, it is called partial dependency. This is the example of second normal form. Consider the following functional dependency in a relation R A, B, C, D. A and B together determine C and B and C together determine D. In the above relation, AB is the only candidate key and there is no partial dependency. That is, any proper subset of AB doesn't determine any non-prime attribute. Another example of second normal form. Consider the teacher table. In the given table, non-primary attribute teacher age is depending on teacher ID, which is a proper subset of a candidate key. That's why it violates the rule for second normal form. To convert the given table into second normal form, we decompose it into two tables, teacher detail table and teacher subject table. The next one is third normal form. A relation in a third normal form if there is no transitive dependency for non-prime attributes as well as it is in second normal form. A relation in a third normal form if at least one of the following condition holds in every non-trivial function dependency x to y. X is a super key and y is a prime attribute. Each element of a y is a part of some candidate key. The transitive dependency. If A to B and B to C are two functional dependency, then A to C is called transitive dependency. Example of one third normal form. In relation student given in table, the functional dependency sets are like this and candidate key are like this. For the relation in a table, the student number, the student state and student country are true. So student country is transitively depending on student number. It violates the third normal form. To convert it in a third normal form, we will decompose it the relation student, the student name, student number, student font, student state, student country, student age as student, the student number, student name, student font, student state and student age, state and country. The another example of a third normal form, consider relation R A, B, C, D, E. A determine BC, CD determine E, B determine D, E determine A. All possible candidate keys in a above relation are A, in, CD, BC. All attributes are on a right side of all functional dependency are prime. That's all now. Thank you.